Hi everyone, today we're looking at calculating simple theoretical probability as well as experimental probability. So our first example is a letter is chosen randomly from the word television. So part A asks us, how many letters are there in the word television? So if I count these up, I'll find that there's 10 letters. Okay, so I've just written that over here, 10 letters. Our next bit is find the probability of different letters. So my first part is the probability of having a V. So the rule for this is that I'll have probability of V, and then I'll have the number of V's over the total number of letters. So when I count this up, I have 1V over 10 letters. The next one is that I have the probability of an E. When I count the E's in television, there are 2 E's over a total of 10 letters. However, I can simplify this fraction. So I know for 2 tens is the same as writing 1/5. So the next one asks us to find the probability of not having an E. So this means that I can do this one of two ways. I can either count up all the other letters in television, or I can use what I already know. So I already know that there is 10 letters in total, and that I can minus the 2 E's in television. And that tells me I have 8 letters left over. So there is 8 letters in television over 10 total letters. So this is another fraction that I can simplify. So I can see that if I have 8 over 10, this is the same as having, well, I'll do it the long way for you guys. I can divide by 2, top and bottom. That is the easiest way to go. So if I divide 8 by 2, then I have 4. And if I divide 10 by 2, then I have 5. So my simpler fraction is that I have 4/5. Okay. My next one is having an E or a V for my probability. So I'm going to write it as probability of E or V. So the probability of this is I've got 2 E's and 1 V. So therefore I must have 3 over 10. So for this one, I can't simplify it any further. But another thing I can do with my probability is to write it as a decimal. So if I want to write this as a decimal, I can go and say 3/10 is the same as 0.3. So to do that, and if you're unsure of how to convert your fraction to a decimal, what I have done is I've looked at 3/10 and I've gone, so if my 0 is in the ones, sorry I'm on a eraser, if my 0 is in the ones, then after that I have the tenths, I have 3/10. Okay. Okay, so now we're ready to move on to our next type of probability. So this is our experimental probability. In this question, I've got an experiment involving the tossing of 3 coins and counting the total number of heads. Here are the results after running the experiment 100 times. So we have a table that says the number of heads, so I can either have 0 heads, 1 heads, 2 heads, or 3 heads, because there's 3 coins, and the frequency of getting each one. So for the first one, we're just identifying from our table. So how many times did 2 heads occur? So if I read my table, then I can go to the number of heads, which is over here, and there must be 36 times. Okay, for the next part, we have how many times did fewer than 2 heads occur? So for this, I'm going to continue to read my table. So fewer than 2 heads is 0 and 1. So for these two different options, I had 11 heads, 11 times when I only had 0 heads, and 40 times when there was 1 head. If I add these two together, then there is 51 times that we had fewer than 2 heads appearing. Okay. The next one is I'm going to find the experimental probability of the next few things. So the first part is I have the experimental probability of obtaining 0 heads. So this is the probability of 0, and I'm just going to write H for heads. Okay, so in this case, I had 11 heads, but this is over, so we're going to have a total, and we're going to have to work out what my total number of trials for our denominator. So we could do this one of two ways. Either I could add up the total of the frequency, or lucky for us, we've been told in this experiment that it was run 100 times. So for each of my denominators, when I'm working out the probability, I'm going to have 100. So for this one, because for 0 heads, the frequency is 11, the probability of having 0 heads appear in my experiment is 11 over 100. So for my next one, I have the probability of obtaining 2 heads. So the probability of 2 heads. So if we look back up at our table, the probability of 2 heads was 36. So I have 36 over 100. And now I can do the same thing for if I have fewer than 2 heads. So the next one is fewer than 2 heads. So I'm going to write probability of less than, 2 heads is going to equal, and we've already worked this out, is 51 over 100. And lucky last, we have the probability of at least 1 head. So the probability of at least 1 head. The other way of thinking about this one is that if I've got at least 1 head, then this is the probability of 1, 2, and 3. Or I can treat it of everything but 0. If I want to work it out as everything but 0, what I can do is I'll look at my total minus 0. So my total was 100 and my score for 0 was 11 times. So therefore I must have 89. So I can do 89 over 100. The other way we might like to work this out, if that doesn't make any sense to you, is you can go the probability of at least 1 head is going to equal, and we're going to add up all the other scores. So we had 40 plus 36 plus 13 over 100. And if I add all these up, I get 89. So that's 2 different ways you can do if you have a question that asks at least. Okay, hope those 2 examples made sense to you and that you're ready to move on to your own textbook questions. Good luck.